Welcome to Day 15 of Wisdom Academy AI, my incredible wizards. I'm Anastasia, your thrilled AI guide, and I'm so excited to be here today. Have you ever wondered how AI mimics the human brain to learn and make decisions, like recognizing images or predicting outcomes? We're diving into neural networks, the foundation of deep learning, and it's going to be magical. I've brought my best friend Sophia to share the excitement. Over to you, Sophia.
Hi, I'm Sophia, and I'm absolutely thrilled to join you today. Neural networks are like the brain of AI, and I can't wait to show you how they work to solve complex problems. We've got a spellbinding demo coming up using Python to classify customer churn. It's going to be amazing. Let's dive into this adventure together and uncover the magic of AI's brain.
Let's recap Day 14, where we explored decision trees and random forests. Decision trees classify data with splits, guiding decisions through a tree structure. Random forests use an ensemble of trees for better accuracy, combining their predictions. We evaluated them with accuracy and feature importance, ensuring effectiveness. We overcame challenges like overfitting with smart solutions, and we classified customer churn with a fantastic demo. Now, let's move to neural networks. I'm so excited. Today, we're diving into neural networks, and I can't wait. We'll uncover what neural networks are and their role in AI. We'll learn how they mimic the human brain to solve problems. We'll explore key concepts like layers, weights, and activation functions that make them work, and we'll build a neural network with a magical demo. Let's explore this brain-like magic. I'm so thrilled. Neural networks are our focus today, and I'm so excited. They're models inspired by the human brain, designed to learn from data. They're made of interconnected nodes called neurons that work together to process information. They're used for tasks like classification, regression, and even image recognition. For example, they can recognize images or predict customer churn with high accuracy. Neural networks are a powerful AI brain simulation. I'm thrilled to explore them. Why use neural networks? Let's find out. I'm so thrilled. They handle complex, nonlinear relationships in data, capturing patterns other models might miss. They're great for large datasets with many features, scaling well for big problems. They excel in tasks like image recognition, speech recognition, and more due to their flexibility. For example, they can predict diseases from symptoms with high accuracy. Neural networks are a magical tool for advanced AI. I'm so excited to use them. Let's see how neural networks work, and I'm so excited. The input layer takes data features, like age or income, as the starting point. Hidden layers process the data, learning patterns through interconnected neurons. The output layer gives the final predictions, like churn or not churn. Neurons connect with weights and biases, adjusting to improve accuracy. It's a magical flow of information. I'm thrilled to follow it. The neuron is the building block of neural networks, and I'm so eager. It takes inputs, applies weights to them, and adds a bias to adjust the result. It uses an activation function, like sigmoid, to decide what to pass on. The output goes to the next layer, continuing the learning process. This mimics how brain neurons fire, making decisions based on signals. It's a tiny piece of AI magic. I'm so excited to understand it. Activation functions are key in neural networks, and I'm so thrilled. They decide if a neuron should fire by transforming its input into an output. Common ones include sigmoid, ReLU, and TANH. each with unique properties. Sigmoid outputs values from 0 to 1, great for probabilities like in classification. ReLU outputs 0 or a positive value, speeding up learning in deep networks. They add nonlinearity to our magic. I'm so excited to see their impact. Let's look at an example. Classifying customer churn with a neural network. We use data with age, income, and purchases to predict if a customer will churn. The neural network learns patterns in the data through its layers. Hidden layers find complex relationships, like how income affects churn likelihood. The output layer predicts churn, yes or no, with high accuracy. It's a brain-like way to classify. I'm so thrilled to see it. Training a neural network is fascinating, and I'm so excited. The forward pass makes predictions by passing data through the layers to the output. We calculate the loss, which is the difference between predicted and actual values. The backward pass, or backpropagation, adjusts weights to reduce the loss. We optimize using gradient descent, finding the best weights over time. It's a magical learning process. I'm thrilled to learn it. Loss functions are crucial in neural networks, and I'm so thrilled. They measure the error between predictions and actual values, showing how far off we are. For classification, we use cross-entropy loss to compare predicted probabilities. For regression, mean squared error, or MSE, measures the squared difference. The goal is to minimize the loss during training, improving accuracy. This guides our network's magic learning. I'm so excited to use it. Gradient descent is how we optimize neural networks, and I'm so eager. It finds the best weights to minimize the loss, improving predictions over time. It calculates the gradient or slope of the loss to determine the direction of change. It updates weights in the opposite direction of the gradient to reduce error. The learning rate controls the step size for these updates, balancing speed and accuracy. It's a magical optimization spell. I'm so excited to see it work. There are many types of neural networks, and I'm so thrilled. Feed-forward networks are simple, with data flowing forward from input to output. Convolutional neural networks, or CNNs, are great for images, capturing spatial patterns. Recurrent neural networks, or RNNs, handle sequences like text or time series data. For example, a CNN can classify images, identifying objects with high accuracy. This variety offers magical networks for different tasks. I'm so excited to explore them. Here's an example, using a CNN for image classification. We use data with images of cats versus dogs to train the network. The CNN learns features like edges and shapes through its layers, identifying patterns. Hidden layers apply convolution and pooling to extract and reduce features effectively. The output layer predicts cat or dog with high accuracy. It's a magical way to see. I'm so thrilled by its power. Neural networks have challenges, but I'm so determined. They can overfit, memorizing the data instead of generalizing to new examples. They take a long time to train with large datasets, requiring significant computation. They need lots of data to perform well, which can be hard to gather. They're also hard to interpret, making decisions less transparent. We'll solve these with magic. I'm so excited to tackle them. Let's overcome neural network challenges, and I'm so thrilled. Use dropout to prevent overfitting by randomly disabling neurons during training. Optimize with GPUs to speed up training, handling large datasets faster. Augment data, like rotating images, to increase the dataset size artificially. Use simpler models like decision trees when interpretability is needed. These are magical fixes for better networks. I'm so excited to apply them. Neural networks have amazing real-world applications, and I'm so inspired. They power image recognition, identifying objects and faces in photos with accuracy. They enable speech recognition, transcribing audio for assistants like Siri or Alexa. They drive recommendation systems, suggesting movies or products on platforms like Netflix. In medicine, they detect diseases from scans, aiding diagnosis. Neural networks are a magical tool for many fields. I'm so thrilled by their impact. Let's compare deep learning and neural networks, and I'm so excited. Neural networks are a general term for models with layered structures, like the ones we're learning. Deep learning refers to neural networks with many layers, often dozens or hundreds. Deep networks are better for complex tasks, like computer vision, due to their depth. They require more data and computation power to train effectively. It's a magical evolution of AI. I'm so thrilled to explore it. Before our magical neural network demo, let's get ready. Ensure Python, scikit-learn, and TensorFlow are installed. Run pip install TensorFlow if needed to have your tools ready. Use the customer's churn.csv dataset with age, income, purchases, and churn, or create it with the script in the description. Launch Jupyter Notebook by typing Jupyter Notebook in your terminal, opening your coding spellbook. Get ready to classify customer churn. I'm so excited for this. Now, wizards, it's time for a magical demo, neural networks in action. Sophia will use Python and TensorFlow to classify customer churn, predicting whether customers will leave, yes or no. This demo will build a neural network to make these classifications, showing the power of AI's brain. It's pure magic, and I can't wait to see it. Over to you, Sophia, to cast this spell.
Hi, I'm Sophia, your demo wizard for Wisdom Academy AI, and I'm so excited. I'm using Python and TensorFlow to build a neural network on a customer dataset with age, income, purchases, and churn, classifying who will leave. Split the data, build the network, train it, and predict churn, look, an accuracy of 83%. The magic of brain-like learning is alive. Back to you, Anastasia, with a big smile.
Wow, Sophia, that demo was pure magic. I'm so impressed. Let's break down how it worked for our wizards to understand. Sophia used Python and TensorFlow to build a neural network on a customer dataset, predicting churn. She loaded and split the dataset, built the model with hidden layers, trained it, and predicted churn with an accuracy of 83%. The hidden layers learned patterns in the data, enabling accurate predictions. This brings brain-like magic to life. I love how it works. Here are tips for using neural networks, and I'm so thrilled. Start with small networks for simplicity, making them easier to understand and train. Normalize your data before training to ensure all features are on the same scale. Use dropout to prevent overfitting, randomly disabling neurons during training. Experiment with different layers and activation functions to find the best setup. Keep practicing your brain magic. I'm so excited for your progress. Let's recap day 15, which has been a magical journey. Neural networks mimic the brain, learning from data through interconnected neurons. We explored core concepts like layers, weights, and activation functions that make them work. We learned to train them with backpropagation and gradient descent, optimizing predictions. Your task: build a neural network using Python and share your accuracy in the comments. I can't wait to see your magic. Visit wisdomacademy.ai for more resources to continue the journey. That's a wrap for day 15, my amazing wizards. I'm Anastasia, and I'm so grateful for your presence. I hope you loved learning about neural networks. You're truly a wizard for making it this far, and I'm so proud of you. If this lesson sparked joy, give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow, we'll explore k-means clustering basics. I can't wait. Sophia, any final words?
Hi, folks, I'm Sophia, and I had a blast with the neural network demo. Day 16 will be magical with k-means clustering, so don't miss it. See you soon.